Hi everyone, welcome to Integral Calculus. Today we explore lesson 5.2, definite integrals, part 1. Number 1, limit of the Riemann sum. Let's say we have a function and we're going to sketch the function this way. This is f of x. We want to figure out the area from A to B. The exact area. First, we're going to cut the interval from A to B into n part. So that is the let delta x equal to b minus a over n. So for a particular rectangle, it will look like this. The width would be delta x rectangle. Say height. Well, we can let A to be x sub 0 and B to be x sub n. So that means this number right here would be x sub I, and the height would be fx sub I. Width is delta x, length is fx sub I. You see that x sub I would just be first number is a plus I times delta x. Yeah. Well, we have the length and the width. We just have to figure out the area, and then we add up all of these area. So area of n rectangle is gonna be the summation length times width. Where I go from 1 to n. And then in order to figure out the exact area from the previous lesson, we have to take limit and go to infinity. And this is the exact area. Oh, pretty cool, huh? Limit and go to infinity. Summation I equal 1 to n. The length is fxi. The width is delta x. This is the nice formula. The first person to discover this is Riemann. So that's why the area of n rectangles call it the Riemann sum. And then when you take the limit, we call it it's the limit of the Riemann sum. Riemann is a German mathematician, very small, very popular. Next, we want to use the formula to, of course, compute area under a curve, right? Because of the summation notation here, we need a few formula to compute the sum. So here come a few formula. Summation formula. Ooh, let's see. First one is the sum I equal 1 to n of I. Is this is what it look like. 1 plus 2 plus 3 plus dot 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 plus n times n plus 1 over 2. B summation I equal 1 to n I square. N times n plus 1 2n plus 1 over 6. C summation I equal 1 to n I to the power 3. And this would be n times n plus 1 over 2 square everything. D, well, if we want to have a summation of I equal 1 to n of c, what this means, that we have c plus dot 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 plus c n times this would be cn. E summation I equal 1 to n c a sub I. This would be, well, the summation here has nothing to do with c, so we can take it outside of the summation. I equal 1 to n a sub I. And then the last one, summation I equal 1 to n a sub I plus minus b sub I. Well, we can split out the summation. Sum I equal 1 to n ai plus or minus sum I equal 1 to n b sub I. Yay! A bunch of very useful formula. Let's take a look at an example similar to what we did in the previous section. So in the previous section, we only estimate the area under the parabola from 0 to 4, right? Now we're gonna compute area under fx equals x squared on the interval 0 to 4. Okay, so it would be this area right here. X, Y, here come the parabola. Force right here. 16. And this would be the area. Okay. So area would be, according to the limit of the Riemann sum, it would be limit and go to infinity of the Riemann sum equal 1 to n fxi delta x. Okay, we got to figure out what is delta x and fxi. Delta x is 4 minus 0 over n. So that's 4 over n. X sub I is a, that is 0, plus I delta x. Let me write a here, which is 0 plus I times 4 over n. And that is 4 over n times I, x sub I. Do the substitution. We have limit n go to infinity. Sum I equal 1 to n f 4 over n of I delta x is times 4 over n. Again, evaluate f of 4 over n I. Limit n go to infinity. Summation I equal 1 to n 4 over n I square times 4 over n. And we have limit n go to infinity. Summation I equal 1 to n. 4 square is 16, n square is n square, I square times 4 over n. Limit n go to infinity. Summation of I equal 1 to n I square, multiply this one to 4 times 16 is 64 over n to the power 3. The summation has nothing to do with n, so we can move 64 over n to the power 3 outside of the summation. So this will be limit n go to infinity, 64 over n to the power 3, summation I equal 1 to n I square. Now we used one of the summation formula to get limit n go to infinity, 64 over n to the power 3, multiply to n plus 1 times 2n plus 1 over 6. Notice that the degree of n in the numerator is the same as the degree of n in the denominator. So the limit would just be the coefficient in the denominator divided by the coefficient in the numerator, and that is 64 times 2 over 6. Which is 128 over 6. Simplify that to be 64 over 3 and 21 1 over 3. B. Find the area under fx equal 1 minus x from 2 to 4. That is from x equal 2 to x equal 4. Okay, sketch this out. x, y. 1 minus x, the y-intercept is 1. Slope is -1, so go down 1, go to the right 1. And that should get us the straight line, because it is a linear function. Two, three, four. Area. Oh, notice that the area is under the x-axis. The area in the example A is above the x-axis. Let's see what happens if we compute the area under the curve, but it is under the x-axis. Okay, area would be the limit of the Riemann sum. Here we know that delta x is 4 minus 2 over n, which is 2 over n. X sub I is a plus I delta x, which is 2 plus I times 2 over n. Okay. Do the substitution here. And this could be limit n go to infinity. Summation I equal 1 to n f of 2 plus I times 2 over n times 2 over n. Okay. Limit n go to infinity. Summation I equal 1 to n. Sub into the function. And we're going to have 1 minus this. So it's going to be 1 minus 2 plus I 2 over n. Multiply everything by 2 over n. Simplify this one. Okay, so 1 minus 2 is -1. 1 minus I to the it's going to be minus I 2 over n. And then I'm going to multiply this by 2 over n. Distribute this, and we're going to have limit n go to infinity. Summation I equal 1 to n negative 2 over n minus 4 over n square I. Okay. Next, I'm going to split out the summation here because we have two of them. We have a limit n go to infinity. Sum I equal 1 to n up minus 2 over n minus sum I equal 1 to n 4 over n square I. Same thing here. I'm going to pull out the negative 2 over n because it has nothing to do with the summation and the 4 over n square. So limit n go to infinity. Negative 2 over n summation I equal 1 to n 1 minus 4 over n square, summation I equal 1 to n I. And now we have limit n go to infinity, minus 2 over n, the summation of 1 from 1 to n is n, minus 4 over n square. Using the summation formula, and we have n times n plus 1 over 2. What we have is limit n go to infinity of minus 2 minus 2, because 4 divided by 2 is 2, and n plus 1 over n square. We have limit n go to infinity of -2 minus limit n go to infinity 2n n plus 1 over n square. -2 minus 2, and that will give us -4. Oh, pretty cool, huh? Well, if you notice that this area is the area of a trapezoid, so we can actually figure out the area of a trapezoid. Right? I hope that you remember how to find the area of a trapezoid. Area of a trapezoid is half of a plus b h. On one side we have a, this is a right here, and this b. H is gonna be the height. This H. AB, they are parallel side. 1 over 2. A is exactly f of 2. B is f of 4. H is just 2 here. 1 over 2. Well, the graph is 1 minus x, so it's going to be a 1 minus 2 plus 1 minus 4 times 2, and ta-da, minus 1 minus 3 times 2. See, -4. Pretty cool, huh? One thing that I want you to know from these two examples is that if the area is above the x-axis, then it will be positive. If the area is below the x-axis, then it will be negative. Thank you for watching. I hope you find the video useful. Please like and subscribe to help the channel grow. I'll see you in the next video.